everybody, and welcome to this Energy Central PowerSession Plus called Predicting Distribution System Outages, the Next Reliability Breakthrough. I'm David Wagman, and I'll be your host and moderator for today's session, which is brought to you by Sentient Energy, a Koch-engineered solutions company. There are lots of customer touch points, as we know, but the one that everyone wants to avoid is an outage. Stress levels rise and the utility is put under the microscope whenever the lights go out. To look more deeply into predictive outage management, we have a full and really informative agenda put together for today. We start with some insights behind what is clearly becoming a paradigm shift in how we address reliability, and we discuss a new approach to electric reliability. Following a break, we'll also take a closer look at the ever-important business case behind preempting outages. Then we look at the change management process that is necessary for truly predictive actions related to outage risks. Just before our second break, we'll look at how the cloud can be effectively used for advanced analytics related to outage prediction. Once we come back from the break, we'll put it all together with a panel session to answer your questions and probe a little more deeply into all of these important topics. So what's in it for you? Well, by the end of today's session, we think that you'll be better able to understand how outages can be predicted and prevented using familiar technology, analytics, and techniques. Today's presentations will help you learn about line sensing and advanced analytics technologies used to predict outages to improve reliability and reduce the risk of ignitions in high wildfire risk areas. You'll hear from one of your peers, a major utility, and gain insight into how it is predicting and preempting outages. You'll gain a broader understanding of change management issues and how to address these in a phased approach. And you'll learn about cloud-based software deployments that enable advanced analytics use cases. So with that, let's go on and let me introduce our first panelist today. I'm pleased to introduce John Villali, who is a research director for IDC Energy Insights, primarily responsible for thought leadership in the area of utility digital transformation. He has an extensive background in the power and natural gas markets. John works out of the IDC offices in Framingham, Massachusetts. You can connect with him by joining the IDC Community Energy blog, which he contributes to regularly. John, welcome, and the platform is yours.
Thank you, David, and thank you everybody for joining us today. It's a pleasure being here, and I think we're going to have a great virtual session on really trying to understand, what's going on the distribution system, the grid in general, and how to create more reliability. You can move to the next slide, please. But to open up, I just to kind of set the stage for today's event and really talk about some of the utility sector's main challenges that they're having, with the grid. And I'm sure many of you are very familiar with this and are dealing with this on a daily basis. But for reliability and resiliency and the challenges that are out there, we have a lot of aging assets around the grid. And particularly throughout the value chain, I think transmission and distribution has been neglected for quite some time. But now with all the disruption taking place on the distribution system, such as EVs and distributed energy and so forth, there's a lot of attention now being paid to the distribution system. In addition to that, I mean, extreme events have been coming up more and more. Frequently, and sometimes I look at the media and think, is the media blowing this up, or is this really happening? But I sit here in New England, and I could tell you that the weather's been crazy. We've had record rain, for the 3 months of the summer, and not to mention all the wildfires that are taking place in northern Canada, both on the west coast and east coast, which is impacting a lot of the air quality. And transmission and power outages as well. Network and grid reliability and communications still, a big issue for utilities. And maintenance in general is one thing that utilities can control. You can't control the weather. Sometimes you can't control the market fundamentals, but one thing that you can control, and it is a challenge, is controlling those operating costs. As the grid advances and as digital transformation advances within utilities, utilities are doing their best to get off of paper-based workflows and make it a digital environment to be able to be more efficient and be able to help workers in the field and operations in general. But there are still challenges with skill sets and labor shortages in general, and in particularly around field work and maintenance, with a lot of utility workers coming to retirement. We talked about communications. There's a need for efficiency and safety, always safety and reliability being top of mind for utilities. And performance management, whether it's from just a reliability standpoint, compliance, safety, always top of mind. And also, just improving constantly best practices, trying to learn from peer utilities and what they're doing. And now more than ever, utilities are focused on the customer, and really customer satisfaction being one, but also trying to understand how their customers are consuming energy, sometimes producing energy, and how they're changing as we're kind of going through this energy transition in a wave towards cleaner and greener energy. And lastly, but not least, obviously regional and piecemeal throughout utilities and utility footprints. But what is the impact on grid connected renewables, as well as DERs, the behind the meter distribution energy resources, which could be a blind spot for many utilities. So we've talked about the challenges. So what do we do about that now, and how do we get that reliability and build that resiliency that's needed? So one thing in talking to our utility customers at IDC, I take a look at technology up and down the value chain with a specific focus on operations within the grid. And what we're seeing and discussing with a lot of the utilities is kind of just moving away from the reactive scheduled type maintenance that has always been there for utilities, and moving more towards a condition-based approach to maintenance and more of a proactive approach. So how do you do that? You do that through digital advancements that will allow for predictive, preventative, and prescriptive maintenance through the use of data, analytics, new technologies and accelerators such as AI and neural networks and things of that nature that can really move in operations forward with greater reliability. So when talking to utilities, really take a look at it in a few different buckets on how to get there. Obviously, first you have to digitize your assets, and then that will allow you to do some remote monitoring and diagnostics. There is kind of where the first steps are for what we call the digital strategies or digital transformation, what we're seeing in utilities. Where I think there becomes a challenge is getting to the next steps on after the monitoring and diagnostics through the use of the data. How do we get to the communications and control piece of that in terms of assets that are out there in the field, to be able to do that in an automated manner, in a remote manner as well? So it's really done through advanced real-time analytics and the ability to take a look at assets and take a strategic approach to asset management. That's taking a look at a lot of data, historical data, taking a look at anomalies in data that's there to try to get in front of issues really before they occur and prevent some of these asset failures. Other technologies and ways to go about it that can make it easier is really embracing cloud technology. I know utilities are a little bit slower than many industries, asset intensive industries, in terms of moving to the cloud. I think it's also a little bit different regionally. I know in Europe, they've moved a little quicker to the cloud than we have here in North America. Obviously, we have some issues around CapEx and OpEx and how we pay for cloud investments and be able to capitalize that and roll that into rate base. So there's a little bit more regulations that we have to deal with in the US, but taking a look at some of the IDC data, there is each year showing more and more adoption of cloud, and particularly around the distribution system. I think when we look at NERC-CIP regulations, a lot of the strict security rules are on the transmission and generation side of the house, where it's a little bit more lenient on the distribution side. That said, I think with all the changes that are taking place, maybe that changes, but we are seeing more cloud, as they relate to the distribution system, whether that be, advanced distribution management systems, distribution energy resource management systems, and all the way down to field services as well. We're seeing decent adoption of cloud. So edge to cloud technologies, are very helpful in terms of efficiency, remote abilities, to do some analytics and get in front of some of these issues before it's too late. One thing that we do talk about quite a bit, at IDC is just taking a operational cloud-enabled approach, platform approach to operations, where you can really start to utilize data and information from core systems as well as key personnel dispersed throughout the utilities. Utilities are historically known for having siloed assets or siloed systems and departments, but really taking a holistic approach to operations can be helpful. So what do we mean by that? It's really trying to connect some of the major systems such as an EAM system, an APM system, ADMS, all the way down to field services on one platform with visibility to all key stakeholders throughout the organization for best efficiency and optimization of your assets. I again just want to stress beyond the monitoring and diagnostics, which is very important because visibility is half of it, and especially when we're talking about distributed energy resources and behind the meter type of blind spots that utilities have. It's very important to have that visibility. But again, I just want to stress the need for advancement in terms of communication protocols to be able to connect, communicate, and control not only grid connected assets, but behind the meter assets as well. And being able to do that in a way where a typical ADMS can be very useful and efficient for a utility, especially when we're talking about outage management, the discussions and highlights of what this event is about. So a lot of that has to do with some of the fault isolation and restoration type of benefits from those type of technologies. So now that we've kind of laid out the the challenges and some of the things and ways utilities can go about digital advancement and really getting in front of some of the outages, providing more resiliency and reliability in the grid. What are the benefits and results that we're seeing through the utilities? Some of the results obviously can be a limitation on unnecessary truck rolls that need to be happening. So if you're able to monitor and diagnose from a remote area, maybe the scheduled and routine inspection rounds aren't needed, and you could just focus on the high risk areas, and that will obviously reduce field worker transportation as well as things like inventory cost and those things. Increased customer satisfaction, we talked about, and I think that's a big thing because not only for reliability, customer satisfaction and safety. And that's really, being able to restore any outages or damaged equipment in a timely manner, and even better than that, prevent these type of issues from happening in the first place. Other benefits are really just getting that holistic approach and a single source of data for an entire operational organization, and other key stakeholders that need data and actionable intelligence in front of them. So being able to do that through technology and digital advancements is key for sure. And in the end, this will definitely provide much cost savings in terms of operational cost savings, and an ROI on any of the investments that you may make in these advanced systems, devices in the field, and other investments needed to be made to take this digital approach. And in addition to all of that, this will help with staying in compliance and avoiding any major regulatory fines. I talked about some of the wildfire issues out there, and this can become a huge liability for utilities as we're seeing some of these wildfires happen. And even if the wildfires don't happen, there are major fines for utilities on not taking care of, let's say, vegetation management or anything else that would be on the utilities' part for not maintaining the grid properly. So in the end, I believe it is all about providing safety, not only for your customers, but also workers, the reliability always being top of mind for utilities, and really this resiliency and grid hardening piece, which is taking place, especially with a lot of the new legislation that is passed here, especially here in the US. We are seeing a lot of government funding and motivation and just a lot of traction in terms of investments going towards the grid and providing the type of reliability it needs. So with that, I do look forward to the rest of these sessions today, and look forward to participating in our panel later this afternoon. So with that, I'll send it back to David.
Thanks, John. Thank you. I'm just taking notes here. You got to feel that your insights into the changing utility landscape are going to be a perfect introduction for a topic that's coming up in just a little bit, which is a deep dive into change management. So this is just a great segue. Thanks very much for that. As a reminder for our live audience today, please send us your questions at any time during the presentations. A little later on, we're going to have a group discussion with all of the panel members to answer as many questions as we can and really keep the conversation going. So feel free to submit those questions at any time. But right now, I want to introduce the speaker who will talk to us about the technology that is at the core of this predictive outage management paradigm shift. To do that, I'm pleased to introduce Dr. Mir Musavi, who's a Senior Director of Advanced Analytics and Applications at Sentient Energy, a Koch engineered solutions company. Dr. Musavi leads a multidisciplinary team of data scientists, power system engineers, and software developers. They're collectively dedicated to researching, developing, and implementing market-leading analytics solutions for the electric utility industry. He also provides visionary leadership and smart grid subject matter expertise to internal and external stakeholders and collaborators, helping the company and the industry advance its market and technology leadership globally. Mir, the platform is all yours.
Thank you, David. Hello and good morning, good afternoon, everyone. It's great to be here, and it's great to be at this exciting time witnessing how advanced analytics and applications make a real impact. When I started in this field about 20 plus years ago, things were quite different. It was very difficult, time-consuming, and our job is to get and collect field data. One of my early projects when I was at Texas A&M University was to study and characterize the underground failures. And in order to do that, we had set up a couple of sites in North Dallas, sponsored by TXG Electric, today's Encore. And the only way to get the data for analysis was literally drive up to the sites once in a while, every other weekend, sometimes on a monthly basis, spend some time going across the fields, hooking up laptop, take a data dump, and then bring to the laboratory and busy for the next month or 2 weeks, essentially. Today, this is all happening automatically. It's happening in real time by exception or as we need it. If you look at the compute and storage, we were limited by the performance of super capable desktop at the time with the early generation of Intel processors, limited storage, limited RAM, limited capabilities, but nonetheless allowed us to do what we needed to do to create the body of knowledge we needed for today's technology. Now, if you look at what we have today with intelligent edge computing, remote wireless communications, elastic and secure cloud computing, we are really blessed that all these three pillars of technology enablers now coming together to allow us to go after the most complex problems that we are facing, and some of them that have been really the holy grail for our industry for many, many years. A great example of that is outage prediction. So that's the use case that we'd like to highlight today, and we'd like to dive into the approach that we've taken. Outage prediction a few years ago for us was a little bit more than a vision. We knew it would be possible. We just didn't know how we would do it, how we do it well, and how we do it at a scale, right? Because we needed to go past design experiments and science experiments and actually come up with a solution that we can scale and create tangible, transformative business outcomes. So today it's my pleasure with our entire team to bring this solution to your attention and talk about some of the technical details behind the scenes, and then continue the conversation from there in order to achieve what the title of the program suggests, the next reliability breakthrough. So with that, PJ, if you want to advance to the next slide. Let's a disclaimer first that we're not going to try to boil the ocean at first. Maybe a decade from now we will. But today we're talking about a subset of outages that are predictable. So if you look at outage records over many months and feeders, you'll see a variation. This is a typical illustration. By no means it's illustration of any particular feeder, but if you look at the two largest categories, in particular vegetation-related outages and outages related to equipment failures, they tend to drive the lion's share of the outages that are also predictable. So just to set the context here, when we talk about outage prediction in this context, we really focusing on these two categories as the good starting point for us to start making meaningful predictions and meaningful impact from reliability, resiliency, and the safety of the system. Next slide, please, Vijay. So how do we do that? We know the problem statement. We want to get to predictive analytics. And why we want to do that? Because as many of you would attest, the best outage is the one that you don't have. It's the one that you can avoid. And there's a second piece to that I think Monica is going to talk about it. In order to achieve that, you need to do some change management. But I'm going to talk about, just focus on how do we avoid outages with predictive analytics. So here is a 3-layer architecture that we leverage in order to go from crude oil to finished products, if I can use the analogy. Crude oil for us is essentially sensor data. At the bottom of the graph, you see the flagship product that we provide, MM3 AI. It's a fully autonomous, self-communicating device. I like to think of it as iPhones on wires without an HMI, and when they are hung on the line, I don't think anybody wants to touch them, so no HMI, but they're fully capable of being the eyes and ears of the grid, so to speak, right? We measure current on the line. We measure E-fail as a proxy for voltage because there is no tethering cable, there's no ground references. We measure conductor temperature and a few other parameters. So those are the key physical quantities that we are measuring. Now we are measuring those quantities not necessarily for interval reporting and producing visibility into what the values are. We are measuring for essentially more or less like an EKG signal of the line. What exactly happening on a cycle by cycle basis? We are at 130 samples per cycle. In some other products, we actually do 250 samples per cycle. And we are at the lowest granular level that you can have with today's technology, which is the waveforms, right? All systems are designed to operate under 50 or 60 hertz sinusoid. That's the level that we need to operate because that's what's needed in order to produce the symptoms that lead to outages and failures. And I'll talk about what those symptoms are. So that's the starting point. That's the ticket to the show. You install these sensors, edge devices, basically spray the system, segment further in terms of 50 customers, 100 customers at bifurcation point, important risk areas, easily installed, 20, 30 minutes really all it takes. And again, there's no power supply requirements. The most advanced version, MM3AI, actually can now write to about 24 hours in the event of an outage. So allows us to actually see and observe circuit condition even when there is an outage, right? Now that's the start, as I mentioned. The next layer of architecture has to deal with the head-end software. And it's an understatement that I think with the latest release, it's shockingly and absurdly capable. It leverages, the last time that I counted, about 24 different technology stack that companies like Facebook and Google and Twitter and others using to enable millions of transactions per day. That's the scale we need in order to make real impact, in order to handle the computation needs, in order to handle transaction that we need between edge devices. Now that end-to-end software essentially is almost like the central command and control, and it's talking to sensors and configurations, changing the parameters. We call them OTAP, over-the-air program and all that. But it's a central control and aggregation point as well that, again, creates the interface to the next layer. Now, the next layer is the central brain of the system. And this is where cloud analytics, secure and elastic computing comes to the rescue, because the problems that we're trying to solve are now beyond what I would say physical explanation that we used in the past to operate and manage the grid. We can't just sit down and write an equation and then implement that in a controller and expect that it'll do just fine over the lifetime of the application, right? The problem that we're dealing with is stochastic. It's changing. There's a lot of parameters that lead to why I have an outage, why the asset is starting to fail faster than it's expected. I just did vegetation management. I still have vegetation issues. What happened, right? So there's a lot of things beyond grid control, beyond the visibility of the operators that ultimately lead to an outage. Now, how do we take care of these complexities? We kind of using the analogies that I think brokers use in their stock analysis, which is called technical analysis. We believe that when these conditions happen on the grid starts talking to us in terms of the waveforms, telling us something is wrong with me. And if you can have a way of analyzing that in the right way, we go from symptoms to a cause. And once we have that cause, then we are able to essentially produce what is shown here, a traffic light concept. For operators, we want to make it simple, right? All that complexity needs to be abstracted out. We don't have time for any of that in the operations, right? So ultimately, our goal is to go from top to bottom and then go from, let's say, 20,000 data points per second, which is what the sensors are providing for each snapshot they're taking, to 2 or 3 indication of, here is the feeder segment I'm watching, and what's the likelihood of the next outage happening in the time frame of interest from the perspective of the sensor site. So we're not talking about feeders and only alone. We need to take them down to the feeder site. Now, this can happen in isolation. So you see the connection point to the rest of the operation system, to SCADA DMS for real-time operations, because if your fault happens, you want to be notified immediately. The interval log data, you want to report that into a state estimator immediately as it becomes available, just like SCADA does today, right? And in the process of producing predictive outcomes, we also would like to bring all the additional data set that could be supplemental to the process, such as weather data, OMS, and others, to make the sensor data rich and to tackle the problem that way. All right, thanks so much, PJ. Next slide, please. All right, let's get a little bit more technical, and I promise this is the only technical slide that I have. The question often asked, what drives prediction? Okay, so there are multiple ways you can go with prediction. In the consumer space, we basically say, hey, if I have a past performance of a system, a human, I can probably predict the future. That's not the approach that we're taking, and I don't believe that's going to work for us. The reason is past performance, as we know, is not a good predictor of the future. Why? Because the assumption is that the conditions that were prevailing in the past will continue to exist into the future. But as John alluded in the beginning, the grid is changing every day. We can't make those assumptions. So instead, what we like to do is, we like to, again, look for the symptoms of a failure. The graph that you're seeing right there, the blue oscillography, is an actual recording of a cable failure in an advanced stage. The beginning and the end is pretty much the normal things that you will see. It's okay, I have, I'm not sure, but 30, 40 amp on the line. The area boxed in red is when the actual eventual fault occurred. It actually caused the fuse to blow in this case. That's why you don't see full loss of load towards the end. But what happens is in the middle, you see those blips, oscillations and up and down and erratic things and all that. That is the precursor to an event. That is basically having sweats and chills before, it's not a good analogy, I know, before having a heart attack. The truth of the matter is, a lot of vegetation-induced faults produce these signatures. A lot of equipment failures produce these signatures. In this particular case, what I'm showing to you is an example at advanced stage where these signatures happen right before the failure. But it's not the case all the time. It actually happens weeks, days, in some cases months in advance. So all we have to do is solve a simple problem. Can we pick up these signatures, these precursors to the events, and start tracking in time so that we can develop a good status indication of an outage being made in real time? Now, can we do that with conventional technology? PJ, next click, please. With conventional technology, the graph on the right is what we're going to see. That's what we've designed the systems to work. In our conventional SCADA and the fault notification processes, we don't want to pay attention to these nuisances. We want to know when things actually happen so we can go about restoration. That's our number one job, right? So from SCADA perspective, you see a flat line. Those are within noise level, within the dead mass, no reported. You're not going to see this in the SCADA by design. Now, click on the next slide, please. So when we need predictive analytics to on the same data set, the precursor anomalies now that you see before that failure is what we need to bring to the picture, what we need to bring to the platform, and what we need to capture successfully and systematically. If you do that successfully and systematically, the reliability breakthrough is within the reach. It is proven. There's been lots of studies by my mentees also as well, and we spent again last few years to do that. It's reality and it's happening. And we'd like to share more results with you in the following session. Thank you so much. Next slide, please. All right. Now, I talked about going from raw data to outcomes. That's the most important technical achievement, but in reality, it's only half of the show. Because, okay, we've proven that it's technically possible and we can do it. We can do it at scale. And we've done this looking at millions of waveforms, outage records, with great partners, great team of scientists, power engineers, really bring an Apple mindset of vertically integrated disciplines. That's what it takes to do it, right? So we passed that stage. Now, the real work is all about how do we turn this into business outcomes? And I'm very glad and very appreciative of Matt volunteering to actually talk a lot more about those steps 5 and 6 on the chart. I'm not going to spend time on those things, but let me spend time on step number 4. Predicting outages, the next reliability breakthrough is not going to be said and done in one step. It's going to take all of these steps. And it's going to be a team sport. It needs to be a collaborative approach into the problem solving, which is not really what we have done historically, right? Historically, you got a system, you got investments and all that. You install it, you get through the initial kinks and all that, you're done. Well, the nature of this problem is we can't just make those assumptions. The machines, AI, ML, learn from examples. And so as those examples change over time, we need to continue to train the system. There is a reason why it's called machine learning, not machine learned, because it's continuously learning, getting better and better. In order to do that, we need that feedback loop, which is step 7 here. So you take the feedback, you're making the predictions, you basically produce an outcome. Now you want to understand what was the result of that outcome, good or bad in any way, because the whole purpose is to continue to well over this machine and continue to make the performance as best as it can be. Now, in step number 4, as I mentioned, the initial indication that we are getting is the status indications. Today we have essentially 3 levels. You are either in okay status, basically no news is good news, right? Green. The next one would be we would put that particular feeder segment into what we call a watch status, meaning, hey, there's something going on, but just watch it for now. If you're gonna do maintenance out there, just let the crew know that there's something there, so you don't have to dispatch for this particular case, but just be mindful of that. The next step is, hey, it looks like we're actually seeing now more evidence. The last one is the alert stage, which is like we use these things to communicate urgency to act today, right? So we are in the alert state. We are in step 4. Now the next question comes in. How credible is the alert? Where do I go? What do I do? What do I look for? Right? It's more or less like saying, I am the Sherlock Holmes now. You're asking me, the dispatcher, my crew, to go out, look for what, right? That's the key piece in step number 4. We sit down with SMEs and our utility. Now they know their feeders. They know the typical problems. They know the exposure to vegetation better than we can tell ever, right? And then we drive down these questions and all the data coming in to really create a prescription that drives decision for the operators and patrol guys. And when they go out there, they have a mindset that something is there. I am the detective. I am the Sherlock Holmes. I will find the cause of this thing and we'll get it fixed before the outage occurs. And that's where the magic really occurs. Everything else is enabler. And step number 5 and 6, I mentioned, is all about then how do we justify it? How do we put the business case around it? And how do we make the paradigm shift towards this mode of operation, right? So, ladies and gentlemen, that's the summary. That's the story of today. We are excited about this potential. I hope that 5 years when we look at this event, you all recognize that this actually was a defining moment for our industry. We are ready. Predicting outages is a reality today. We are doing it today. We are ready to deploy and scale and go after these tough problems in the interest of better reliability, better efficiency, and getting a good handle on destructive wildfires. In the background that you see, I'm in Silicon Valley. A typical day in the valley would be 60, 65 with blue, clear skies. It's nowhere near that. The reason is the smoke from the wildfires up north in California has come down, and over the last few years, it's been hazy and smoky, and I think air quality, the last check was 130 or so. So it's real, and you don't have to be near the fire threat areas to be impacted. You could be many, many miles away. The problems are real, the solutions are real. What's left for us is coming together as an industry and going after these challenges. Thank you very much. Appreciate the opportunity. With that, I'll turn it over to you, Dave. Thank you.
I mean, hey, thanks very much. Mir, I'm going to ask you to stay on because we want to bring John Valali back in. Also, we've got a couple of questions that probably are worth covering before the end of our first hour here. So I'll have, if you both could hang on, I would appreciate it. Mir, I've got a couple of kind of technical questions for you, which I think would be worth covering. What are the differences between using data from line sensors along a feeder as opposed to from a single data capture device in the substation? Could you talk a little bit about that?
Yeah, absolutely. I'd like to maybe start from an analogy. What do we think is the difference between if you go and take an X-ray of a chest versus an MRI image, right? It's the level of details. It's the data requirements for the kind of problem you're trying to solve. Now, data from substation, we've been using for many, many years, and we will continue to use that. It's a good supplemental data from one point in the system. The reality is that the type of problem, the culprit that we're looking for is so subtle and so varied in terms of its frequency range that we can't just necessarily look for its 50 hertz or 60 hertz fundamental component, which is really what we actually pay attention from substation measurements, right? Relays, IEDs. I've done that with ABB for many years, right? So we need richer representation of that data, and that's going to be in various frequency ranges. That's why we need to go to microseconds level. That's what GPS synchronization is important, because we also need to see it from different locations on the feeder. And physics in this case is against us. Some of those high frequency oscillation, high frequency arcing, whether it's shunt or a series on the line, a small crack, insulator and all that, they won't make it into the head of the feeder. The circuit itself is a low pass filter. It'll dilute, it'll help attenuate a lot of these signals. So we don't actually see a lot of these things if all we are relying on measurements from the head of the system. And then if you look at the back end of the process, let's say if you are successful in detecting it. I talked about step number 4, 5, and step 6. The dispatcher, the patrol, the field, Sherlock Holmes, they need to have some idea where to go and look. How do we guide them to a better location so that it's not a lifeline endeavor in terms of looking for the culprit, essentially? So again, the data is complementary. Whatever we have done, to your point, John, right? We got to take a platform approach. This data alone will get you a good starting point, will solve vast majority of your problems, no. But it doesn't mean that we can't use other data sets. It's just that we have to complement, and essentially that's what the platform approach is all about. How do we essentially, we made all these investments. How do we take advantage of it?
Hey, John, let me ask you a question. Do you have an estimate or an idea of the number, the percentage of utilities that have or that plan to deploy applications in the cloud, and what kind of applications are going to the cloud?
Yeah, thanks for the question, David. Yeah, at IDC, we obviously have a lot of data, and we put out surveys each year, global surveys, and one of them is around cloud and cloud adoption, and we do it through several different industries, utility being one of them. So I've taken a cut at the utility data to get some insight on kind of cloud, the acceleration of cloud and cloud adoption. So one of the questions was asked on kind of where are utilities currently using cloud, and where do they plan to deploy cloud within the next 12 months in different categories. So some that relate to the topics that we have here. For example, field service applications. Out of 120 utilities that were surveyed, 46% had replied that they're using cloud for field service applications, and within the next 12 months, 31% of those respondents plan to deploy field services within the next 12 months. Another category is around outage management, particularly on the distribution system. 44% of utilities that were surveyed are currently using cloud for outage management, which to me could be a typical standalone outage management. Could be part of an ADMS, it could be part of a traditional DMS, but 44% there, where 33% plan to deploy outage management systems in the cloud within the next 12 months. Another one is around distributed energy resource management systems. And I spent a lot of time in taking a look at this area. And many of the DERMS applications are mostly going to the being deployed on the cloud. But when I do talk to our vendor community, because IDC has vendor customers as well as utilities, I always tell them you need to have a flexible deployment opportunity, especially with utilities and the utilities in the US, as different utilities are at different stages and with the regulations that are out there. But with distributed energy resource systems, very similar figures in the area. 44% are currently using cloud for DERMS, and 36% plan to deploy DERMS on the cloud as well. There's a couple other categories that fit into our discussion. One is around grid analytics. Grid analytics, they have 43% of the utilities surveyed are using cloud, while 35% plan to use it within the next 12 months. So, as I mentioned, I think the use of cloud is very beneficial, and sometimes, depending on the utility you're speaking with, it could be a sensitive subject or a subject they may not want to talk about because they just want it on-prem. And when we talk about the CapEx OpEx issues within, particularly here in the U.S., and the ability to roll it into rate base, sometimes we are seeing utilities, even though they may not be able to roll it into rate base, still moving towards the cloud deployment, only because I think you really have to take a look at cloud from a long-term point of view. I think if you look at the sticker price on-prem versus cloud, you may say, no way, cloud's way too expensive. But you really have to kind of take that longer-term view on the efficiency, the total cost of ownership, maybe some of the ability to free up some of your IT staff to do other more important things, than managing cloud. And I think, a lot of utilities are kind of buying into it. And I think that's where a lot of industries are going, and the utility industry as well, even though a little slower than others, are moving in that direction.
Good insight, thank you. Mir, let me ask you if you could offer any recommendations or any insights into if a utility has its own analytics team, does it make more sense for them to handle that analytics works themselves, or look for a solution provider to do that? What kind of what goes into making that decision?
Yeah, thank you, David. Great question. We often get asked about that. PJ, I'm not sure if you can go back to slide, but if you don't, that's fine. If you look at the entire workflow, yes, thank you. Step 1 through 7. I mentioned this is a team sport. This is like a relay, right? So imagine if you are in a relay 4x400, whatever your favorite is, and then you're running and you're the second in the line, you're doing the last leg. Would you prefer to take the baton from where it is and then keep continuing the journey? Or would you rather take the baton, go back to the early starting line and then start there, essentially, right? So the answer is obvious. I think it's the same thing over here. I think that steps 1 to 3 is heavily influenced by the instrumentation, the OEM, and how the sensors react. I'll get a little bit into details on this. Our sensors use Rogowski coils. It's not very common in our application because we use conventional CTs and PTs. They have a very different characteristics. And part of the reason we use them are they are very sensitive devices that react very well to DIDT. For those that are technical, DIDT is a rate of change of the current with respect to time. And that's what we need, right? If you use conventional CT, PT, they are very slow. They're not going to react as fast and all that, right? So there is a special knowledge base that we need to apply when you take the data from the sensor perspective, put them in the right context of what we think is the measurement, what we think is the noise, what we think is the power system behavior, and kind of combine all of that. And we've encapsulated all of that in the platform itself, in the engine that I talked about in step number 3. Millions and millions of custom-built code specifically to address these things, right? Now, as I said, that's half of the show. So whenever we're talking about the analytics team within utilities, if now again, take John's platform approach, we have other data set that could very well supplement this data set to essentially solve the problem at the bigger stage. If I have drone data, if I have satellite imagery data, if I have AMI, well, I can now start combining, basically take the outage, take the baton from us, distill indications from the electrical signals that we are measuring and monitoring, combine that with the rest of the data set, and go after definition of a larger problem with more accuracy, with more definitiveness and all those things, and really start leveraging all of those investments. So my preferred approach is going to be collaboration. Let's figure out what those use cases are, where we can help, and one of the values that within Coke we certainly talk a lot is what we call comparative advantages. Let's use each team's comparative advantages to the maximum, because at the end of the day, our goal is to make the skies clear again, right? How do we do that efficiency? That's really the kind of the ultimate goal. And so it's all about collaborations. I think there's plenty of problems still to solve when you look at the broader picture with all the data, and we're happy to be part of that process.
John Zalala, do you have anything to add to that, or?
No, that was a great response. I think Mir's hit it on the head for sure.
All right. Well, Mir, I've got another kind of technical question for you. Is the solution that Sentient Energy offers, is it able to detect solar and DER injection issues like over voltage?
Yeah, interesting question, and I think that's another, let's say, milestone. I won't mention the client or the partner that we're working with, but I can probably guess there's a high penetration of solar in one of their feeders. And in one of the observations, we got an alert on a particular issue, and it turns out to be the exact moment, I'll emphasize, exact moment when the flow was reversing on the feeder, right? So the flow was, let's say, north to south, and then all of a sudden we had a flow that's reversing south to north, so to speak. And it was essentially, I believe it was like 9 or 10 o'clock in the morning and all that. So yes. And when you get down to the waveform level, again, that's the most granular data we can get reasonably today with our technology. I don't know what else we could do, in the next 10 decades or so. But when we get down to that level, yes, you can observe these issues. What do you do with it, and how do our business values and all that? Sure. I mean, maybe the first thing is just understanding that you can see it, you can detect it, and the next question is, what do you do with it? What's the value essentially? Because at the end of the day, analytics are good, but I oftentimes said, what start with the end problem in mind? What is the end problem and all that? So technically, yes, you can see it. You can capture those moments and all that. The next question is going to be, what do you do, and then how do you help operations with that knowledge?
And Mir, I've got one last technical question for you before we come up to the break time. Could a utility get the necessary oscillography from existing protective relays and recloser controls? Did I pronounce that right, or am I completely off?
Yeah, I think it's a little bit of repeat, and I probably make a short response to that. Oscillography data available through reclosers and controls, and perfect supplement to the tool set, so to speak, right? Now, again, we'll have to think about the data requirement, the synchronization, and more importantly, what is the trigger point for the oscillography? Today, the way we design and operate the systems, we basically say, if the fault happens, I want an oscillography. If a pickup happens and no trip, pickup means I satisfy some of the conditions, but I didn't satisfy all of the conditions, so I'm not going to open the circuit, so there is no trip. But I pick up. I say, okay, I want to get the oscillography. But if you wait that long to get to the pickup or a trip, for predictive analytics, for outage management, it's too late. It's already done. It's happening. And it's great. We want to know that. We want to understand that, because again, we also want to say, okay, now that the outage happened, what else do we know about the outage? Where it is, what type it is it evolving? Is it a one-time shot and stuff like that? So that's why any data is important. Just that you have to be mindful of what problem we're going to solve, and some of the challenges with the conventional technologies are that it's available, but now there are new use cases. So sometimes it feels like we're putting the horse before the cart. Nonetheless, again, platform approach, all the data is valuable. We just need to figure out how to extract that value by combining and bringing all these platforms together to really create a holistic view of the system.
Good stuff. Well, Mir Mustavi and John Vallali, thanks very much for staying on to chat for a little bit. As we come up to the first break, we'll have both of you back later in the program, of course, for our full panel discussion. And next up, we're going to hear from a major utility on their experience using this predictive outage solution that we've been getting an introduction to so far. Right now, it's my pleasure to welcome Matt Henry, who is the Director of Grid Modernization at Consumers Energy. He's been with the utility there for 10 years in a variety of emerging technology and grid integration roles. Matt holds a bachelor's degree in electrical engineering from Michigan State University and an MBA focusing on business intelligence from Baker College. His passion is shaping a brighter and greener grid of the future. Welcome, Matt. We're glad to have you. It's all yours.
Thank you, David. And hello, everyone. My name is Matt Henry. I'm the Director of Grid Modernization at Consumers Energy, which is an electric and gas utility in the state of Michigan. And I'm excited to be here and talk about a new reliability tool in our toolkit. So first slide, please. So first, I'll set the stage by talking about Consumers Energy and our electric system. So looking at the map you see there on the left, our electric service territory is the majority of the state that is north and west of the mitten. So this portion here. As you can deduce from the night sky satellite image, we really don't have any major urban metropolitan areas. Our largest metro area, Grand Rapids, does have a population of just under 200,000. But our electric system is mostly defined by rural, longer length, and a lot of wooded areas. And so here's a hint, this is foreshadowing for future slides. Our system has over 80,000 miles of overhead low voltage lines that feed our nearly 2 million electric customers. So that's a little bit about Consumers Energy. My role at the company is to modernize that electric grid. So I have a team of engineers who are tasked with the research, the testing, the planning, the design, and the implementation of new technologies all throughout that grid. One specific technology that I'll focus on today is called line sensors. So these 6.5-pound boxes made by Sentient Energy, they attach right onto the power lines themselves, and they monitor and communicate real-time status from the grid back to our control center, into a cloud-hosted software as well. So Consumers Energy, we're in the midst of a 5-year, 12,000 device sensor deployment, adding those eyes and ears all throughout the grid. And for perspective, about 10 years ago, when I first started with the company, you could count the entire population of remote communicating devices on our low voltage system with your fingers and maybe a couple toes as well. But there were only a few handfuls of remote communication devices on the entire LVD system. So that visibility, the remote visibility just didn't exist only a decade ago. This year alone, we've deployed over 2,000 sensing devices. So that really speaks to the rapid change in the industry. We as utilities are getting really good at capturing grid data. And now it's about what are we going to do with it. So going back to line sensors, a primary driver for installing these line sensor devices in particular is that they're capable of detecting and alarming on fault conditions. So this provides an early indication for where our customers are experiencing an outage at that time. So by quickly pinpointing the location of the outage, it narrows our focus and minimizes the area that we need to go look to find out where that grid issue originated. So the benefit, this benefits our customers by reducing the time it takes our crews to travel to and then diagnose an issue. And it shortens the duration of the power outage and improves our reliability. So next slide, please. Reliability is one of our company's, most utilities' top priorities. Our company mission is to provide world-class performance with a hometown service. But due to some of those factors that I mentioned earlier, rural circuits, long length lines, heavily wooded areas, it can sometimes take a very long time to locate where on the grid that issue originated. Historically, Consumers Energy, our company has been in the 4th quartile for reliability performance when we compare to peer utilities in the Midwest. This is measured by a common reliability performance metric called SAIDI, which is the System Average Interruption Duration Index. SAIDI basically represents the average outage duration for each customer served. So this past year, our company made a reliability stand. We've acknowledged that our customers deserve better. They deserve a more reliable service. And so we asked ourselves, what else can we do to improve reliability? So the goal is simple. We want fewer and shorter power outage for customers. So now how do we achieve that goal? We are expanding and increasing what I'll call the traditional reliability improvement efforts. For example, we're ramping up our forestry efforts. We're doing more sectionalizing of the grid so that the impact of any one grid issue impacts a limited number of customers. We're adding automation so that power can automatically reroute after an outage to provide energy from a different direction and minimize the impact of an outage again. But those efforts alone are not enough. We've acknowledged that we can't keep doing the same tactics that we've been doing and expect to see some new results. So breakthrough results require breakthrough thinking. Next slide, please. So what we did is we dug into the outage data. A key finding from our analysis was that restoration efforts were significantly costlier when they're done reactively as compared to proactively. Some reasons for this. Not all outages occur right in the middle of the day. We often respond on weekends, in the middle of the night, and during larger unplanned events, we'll even sometimes bring in out-of-state contract crews. So that same job that they might be doing, if done proactively, comes at a much cheaper cost. And so if we can fix grid issues before they fail, when we're prepared, when we have all the equipment on hand during that first trip to the location, and during a blue sky, clear day, the math shows us that on average, that's a 70% cost savings. So then we asked ourselves, how do we shift that reactive work to start being more proactive? In order to do that efficiently, we need to know the right places to send crews and move work out of that reactive bucket. So this is when we started working with our partners at Sentient Energy to pioneer a brand new approach to how we proactively look for grid issues. We wanted to develop a strategy that leverages our already deployed line sensors and then more effectively utilize the data that we're already collecting. So again, we looked into our outage data. 2 of the top 3 causes of outages for us are vegetation and equipment failures. Both of those are potentially predictable events, like Mir talked about earlier. Of course, not all equipment failures are going to be a slow burn that provide early indication before they fail, but there are many that are. Likewise, not every vegetation outage is led up to with momentary contacts prior to the sustained outage. But for the ones that are, those are the ones we're interested in looking for and finding. And so how do we use that predictive data to prevent outages? Next slide, please. That's where the RAMP program enters in. So RAMP stands for Reliability Analytics Monitoring Program that we're developing with Sentient Energy. So earlier this afternoon, Mir talked about how the machine learning AI technology works, how the sensor's waveform data can reveal signatures that predict future grid disturbances. So right away, we were excited to work together and conduct a proof of concept, proactively identify, categorize, and respond to those grid anomalies. The grid anomalies are what I call disturbances in the forest. So next, click forward, please. So these disturbances in the forest are there, but an important point to make is that prediction data alone does not fix any problems. Like Mir was mentioning, those last 2 steps in the process. The real challenge is to develop a new standard methodology for how do we respond once we find those. So we are developing a process including cross-functional company stakeholders that not only looks at the data, but acts on it. So we're creating deliberate steps to mitigate the grid disturbances and then achieve reliability benefits. Next slide, please. So with Sentient, we focused time on developing an approach for how to strategically roll out the RAMP program. This resulted in a two-phase approach where we start small and validate both the technology but the process as well before we grow to a large statewide implementation. So to start, in phase one, we enabled the machine learning analytic capability on 1,000 sensors spread across 3 of our 30 headquarters in the state. So in those 3 regions, we worked very closely with the local circuit planners. Those are the engineers who are responsible for planning and inspecting the system for those 3 regions. And so any grid disturbances that we observed from that first phase of sensors were categorized into the watch, warning, alert status that Mir mentioned earlier. And then we worked with those engineers to go conduct field inspections, validate that that specific zone where we're predicting that there's an issue, that we can find something. So those line segments were where we drove out, field inspected, and found anomalies. In phase one, we intentionally did not go straight to our operations and forestry teams. So we wanted to first build that confidence in the tool, develop the learnings, and create a standard process before we expand and bring in the field resources. So our thinking was that we wanted to have a handful of wins. We wanted to be able to showcase some success stories that prove the technology, where the platform predicts an outage, we field inspect the zone, and then we find a clear and obvious sign of a grid issue, and then bring it to our field teams. So that was especially true for forestry, vegetation outages. I'm guessing other utility folks who are listening in can relate, but our foresters, they don't want to, and they can't afford to visit every pole in our system every year and make sure that it's in good shape. Especially we have, like I mentioned earlier, 80,000 miles of overhead lines. It's really important to prioritize the forester's time and only request demand trimming in truly emergent areas outside of their normal trim cycles. Another key step in the phase program was, in phase one of the program, was to develop the process for supplying outage data. In order for the machine to learn, we need to keep training it and giving that feedback loop. So that is outages assigned with cause code so that we're continuously improving the analytic and really building the learning until it's smarter and smarter over time. One benefit that we found from this phased approach was during the ramp up of RAMP was that it helped us ensure that we maximize the value of the program. We were able to define the right criteria for what was deemed actionable. Based on the quantity and the frequency of the anomalies, we could then decide what is the right criteria for deciding if a location is something to just keep an eye on and monitor, or do we act on it right away? And I think that's been working very successfully. Next slide, please. So over time, our circuit planners who've been involved have really started to love the program and get excited about, all right, I want to go out and find and proactively fix this issue. So in one specific example, RAMP Analytic flagged an alert. As Mir explained earlier, we observed a symptom of a potential future equipment failure. And so we looked at the map. We had the local circuit planner drive out the zone downstream from that line sensor that reported the finding, and they found a broken insulator. As you can see in the picture on the right here, the top phase conductor's insulator cracked and was only being supported by a bracket on the side of the pole. Luckily, this hadn't yet created a permanent outage, but you can see why we were detecting an anomaly. It's unusual results from the waveform. So we acted quickly. We found the inspection, found this, took this picture, and we acted quickly, dispatched a crew who fixed this issue. Had that upstream device, upstream of this pole, had that tripped due to a fault condition, 94 of our customers would have lost power. And so what we did, based on the average restoration time that it takes historically for that particular circuit, we could estimate that this proactive response avoided over 19,000 customer outage minutes. We avoided that by proactively avoiding an outage from occurring. And another example, one that we're working on right now actually, is a location where we've seen repeat grid anomalies. We're seeing them repeat. And it's likely indicating that there's a vegetation contact. That's what the waveform signatures are indicating. And so in addition to the anomalies that we see, the line sensors are also detecting that upstream protective device, that recloser, has occasionally tripped and then reclosed. And so it's not a sustained outage, but there are momentary blinks of the lights in the same location. And so in this case, what we're going to do is send a local forester out to the exact location where we did a field inspection and found that there are tree branches that are showing clear signs of line contact. So another example of a successful ramp detection issue, we go out and we find, yes, this is where we believe this is happening, and let's proactively fix it. Next slide, please. So we'll continue tracking these types of events moving forward. We're sharing both the realized benefits, so those where we proactively correct and mitigate the issue before it happens. Those are realized benefits, but we're also tracking the unrealized benefits. So those locations that, had we had an established process in place, we believe that we could have prevented an outage. We had the indication, and if there was time to go out in the field and correct it before, we could have avoided that outage. So we're also tracking those unrealized events. And we've seen exciting results so far. So we've really progressed from what started as a proof of concept to now establishing new standard processes in the company that will support our annual reliability stands both now and into the future. So moving forward, we plan to expand the program. So like I mentioned earlier, we started with 1,000 sensors, and we are actively doubling that to 2,000 sensors. So we're growing how many sensors are running this analytic capability on our system. Additionally, a portion of the new wave of sensors are being dedicated specifically to our 46 kV, 46,000 volt high voltage system. So this is a new portion of the grid. And that our HVD system, high voltage distribution system, has potential to provide larger benefit. There are a greater number of customers fed from our HVD lines, and outages to that system can be more impactful. So if we can catch an equipment failure before it fails on that system, I think we'll have much more positive benefits from those if we can catch them early. Another next step for us is that we plan to include this proactive monitoring and response into our company's wildfire mitigation planning process. So in fact, we've intentionally targeted high-risk wildfire areas of our electric system, of our territory, so that the next wave of deployment of the technology is in those high-risk areas, and we can catch any vegetation contacts as they're happening. In addition to the wildfire risk, another key area of focus for Consumers Energy is around the impacts of climate change. And so our company's analysis of weather patterns in recent years shows that the last 4 years have recorded the highest wind gusts in the past decade. So we're anticipating that strong wind events are likely to become more frequent as climate change increases the frequency of storms. We're also anticipating that climate change will increase the frequency of extreme heat conditions, which tends to increase loading on the grid as customers use air conditioning more often. And higher loading can lead to more frequent equipment issues. If we start loading our equipment higher, you typically could see more frequent equipment issues. So the use of grid sensing and proactive analytic technologies is expected to be increasingly important for us moving forward, and I expect it'll be a central part of how we effectively operate and maintain the grid moving forward. So the last note that I will leave you with, our former Consumers Energy CEO, Patty Poppe, who's now CEO at PGE in California, she used to say that her favorite megawatt of electric generation was the one that we didn't need to provide because we could offset it by a demand response program. So my favorite outage is the one that we prevent from ever happening. It doesn't happen at all. So finally, last thing I'll say, I'm excited to continue to grow and expand this program, provide a brighter future for Michigan and our customers. And thank you all for tuning in. I'm looking forward to the questions at the panel at the end. But David, that's all I had, so I'll pass it back to you.
Hey, perfect. Thanks, Matt. What a great presentation. Really, really informative. I appreciate your putting all that together. We've heard earlier from John Valali, who offered great insights into the challenging utility landscape, and Mir Musavi and Matt, as you just heard, expanded on that by introducing to us a powerful analytics tool that can be a valuable part of any utility's effort to predict and preempt outages. One key consideration that I think is really interesting involves change management as the utility moves to fully embrace predictive analytics as part of its ongoing approach to business. For that part of the discussion, I'm pleased to introduce Monica Young, who's a senior management consulting executive with Accenture. She works in the utilities sector for more than 20 years and leads the firm's Midwest utilities, chemicals, natural resources, and energy strategy and consulting practice, overseeing Accenture's solutions to generate value for client businesses. Monica, it's great to have you take part today. Please, the platform is yours.
Well, thank you so much, David, and thank you for having me here today. We've heard some fantastic things from both our previous speakers around with Matt and Nir and John. And if you can go to the next slide here. So 20 plus years ago, probably even 15, utilities in the control center were using paper maps, right? The control centers operated, and I was part of an emergency response during a pretty extreme weather event. Largely speaking, the control center managed a lot of the events with paper-based mechanisms, maps, sticky notes, push pins. That has, basically evolved a lot since then. And so if we think about what has actually changed over the past 15 to 20 years, we have actually introduced a lot more technology at their fingertips. However, if you ask the question, what is 8 here? And if you go to the next slide, well, 8 is the average duration of our customers experiencing outages. And this actually used to be about 3.5. Now, largely, most of this is driven by extreme climate events. However, will that, as we had just heard from Matt, these extreme events are anticipated to take place, even more so. We also have aging infrastructure, which also increases risk. We also have higher customer expectations that when it comes to grid uptime, that the grid is available for that use. But if we think about what does that really mean for our customers, especially those that are most disadvantaged, you will see that in those particular areas, that they experience a higher number greater than 8, and they don't have the capital, infrastructure within their house or other types of mechanisms to, to basically provide a backup generation in their homes. So they do have, that if you take into consideration those customer impacts, that 8 is very impactful for them. So I do have no doubt that employees in general, especially within the utilities, will respond to events. However, we just talked about the fact that infrastructure, in terms of aging infrastructure, increasing climate events will occur. So will that perpetuate us into a potential state of reaction as a result? So if you go to the next slide, my challenge would be, what if the lights stayed on? Can we break free proactively from this potential cycle that is going to occur? Are we able to chart our own destiny by making informed, data-led decision-making? And will us as a utility industry earn the right to continue into that new energy transition future? Because our customers expect it. They expect grid uptime as a whole. And so with that being said, we do have a case for change. And we have a case for change to really look at our culture, our processes, people, and technology to evolve to that state where we have minimal outages in the future, especially even in the context of increasing climate events. And it will be challenging, and we have to look into a bunch of different dimensions to be able to address that appropriately. So if you go to the next slide here, there are going to be table stakes. Table stakes are, as you implement these programs around change management, table stakes around making sure the right stakeholders are engaged, that your employees are trained, communications are, broadcasted, and also that there's ongoing training that's incorporated as part of that plan. However, if you really think about extending this beyond the capabilities that you need in order for us to have a proactive, data-led behavior, what does that truly mean? I think there's a few concepts here. One, customer centricity. There is an aspect of making sure that every single one of the employees within the organization understand how this data and how this could impact positively the overall customer experience. Secondly, understanding your own culture and the people and the mechanisms with which they operate in. Do you have a reactive culture? Do you have, other elements of the culture that you can tap? Truly understanding what drives your people so that way you can craft the entire program to change parts of that behavior become increasingly important. The second aspect is really developing an integrated process framework. No doubt, I believe that when we think about outage prevention, there is significant opportunity and a business case to be able to address outages proactively. However, a lot of the utilities that I work with struggle with the concept of how does emergent work get prioritized in the context of planned work. There is always an infinite amount of work that is out there to be done, whether it's construction, whether it's other reliability reinforcement, there's emergency repairs, and then there's this other aspect around addressing hazards. That framework needs to be really truly laid out with a combination of different stakeholders. Those stakeholders range from individuals from control center operations, your field construction or maintenance crews, as well as engineering, and as well as the individuals that manage the contractors who might be performing your vegetation management. And so I stress this as being a very important aspect of the change management plan, because without defining the priority, as you scale across broadly throughout the organization, there might be competing priorities that are going to be a challenge with respect to who actually has the right roles and responsibility and the accountability to be able to implement, the solutions to proactively address these prevention measures for outages that occur. And so I would emphasize that, seasonality, as well as the understanding of the particular area that you have in terms of that network and the vulnerabilities within that network, become an important emphasis in understanding that overall risk framework that you're trying to build. The other aspect is the consideration around governance. So oftentimes we train and then, we roll out a process, but how do you actually build that into the day in the life? The day in the life of the employees, where it becomes another muscle memory. And it becomes very clear that there is a level of prioritization, and I know how to prioritize this work amongst other work that exists out there. And how do you govern that process? And how will you measure and also adjust your processes to adapt? The fifth aspect to consider as you think about your overall change management plan is how do you embed a continuous talent agenda with regards to improving the data, but also the integration of that data across different areas. So we talked a bit, Amir talked a bit about data and the fact that this is one portion of data that's available for the utility and control center operations to help make decisions. However, if you take a look at the overall, that data in alignment with other portions of data regarding work. I think that there needs to be a broader input into that cost benefit analysis in regards to all the work that exists out there, so that you can actually develop a prioritization framework that can be used to guide folks into their day-to-day operations. And so there's a lot to unpack in the context of, the human behavior element associated with this. Again, I would emphasize that there are table stakes with regards to, like I said, training, communications, stakeholder engagement, and then also developing an ongoing program to reevaluate. So it's not just a one-time rollout, that it keeps, you're able to continuously improve upon all of these processes. And then I would also emphasize that if you think about your change management plan, there are other 8 different considerations to consider. One is the commitment of your senior management leadership. Are you aligned across different organizations with regards to the prioritization of that work? How do you actually develop the emphasis that it's not just the control center and certain field employees that are going to be responsible for that outage prevention process? Secondly, are you able to cultivate that from an employee standpoint, that this is truly a better way to operate and better way to address the reliability of the grid? Building that momentum amongst the employees is absolutely critical, and that starts from the field employees to the coordinators in the back office, their supervisors, as well as the other engineering staff that is there to support them, and within the control center operations group. Then number 3, I think that we have to share the results and share that data, especially when it comes to successes. Matt spoke about it very well in terms of being able to share that business case. I think that being very open about that and getting the employee feedback on how to improve processes, improve barriers, and remove barriers that may be preventing them from doing certain things is very important. And I emphasize that responsibility is not just within the control center and a small group alone. As you scale that, I think that there is responsibility across different lines and different parties within the organization to be able to achieve those joint business outcomes. The 5th aspect is thinking about performance management from a risk and reward standpoint. Oftentimes in certain situations, especially as we get into a very reactive environment, we do often reward heroes. And heroes, it's very great, and we absolutely need them. And we also should reward those who are proactive to prevent a situation from happening as well. And so that aspect around rewarding that proactive behavior is a critical part of how you think about creating a change management structure that allows you to encourage that behavior as you move forward. 6th aspect, I think I overemphasized on it, is the employee engagement. I'll talk about it at least 7 times, so it becomes embedded as part of your change management approach. But getting the employees, involved as part of whether it's understanding the data, how it impacts them, being able to have them help craft the message around how this is a better way to operate is absolutely critical. And then I think the other aspect is getting back to being able to integrate this into your day-to-day operations. How does this become just a standard way of practice? Using this data and this tool becomes just as natural as using the maps that have existed for so many years. And then the eighth aspect that I will reemphasize is customer centricity and empathy. Understanding what it means to our customers, reinforcing the aspects around trust with respect to reliability is absolutely key to make sure that the utility, as they move forward, continues to earn that right to be part of that new energy transition future that we've all emphasized and talked about. And so I will conclude with that comment because I think that being part of the utilities culture will help frame and help us change behaviors and be more proactive as we move forward and allow us to have a very high level of success with regards to grid uptime and outage prevention. So with that, David, I will hand it back to you.
Great, thank you, Monica. Thank you very much. Looking forward to addressing some of the issues that you've raised during your presentation during our panel discussion, which is coming up in just a little bit. As a reminder to everybody, we are still taking questions for that panel discussion that is going to include all of our speakers, and that gets underway in a little bit later on during the session. Feel free to take a moment and send your question to us, and we'll do our best to answer as many as we can during that panel session. Now it's my pleasure to introduce to everyone Peter Kirk, who is a business development principal in the power and utilities segment at AWS. In his work, he develops and executes business cases linking the energy transition, customer experience, and grid modernization by translating AWS technical capabilities into business value. He holds a joint master's degree from the Johns Hopkins School of Advanced International Studies and the Wharton School. Peter, it's great to have you today. The platform's all yours.
All right, thank you. Thanks, David. I appreciate it. And thanks everybody for being here. I'd like to just introduce myself and introduce the group that I'm in at AWS. At AWS, I'm in the AWS Energy Group. It's a focused strategic industry group that looks at industries like automotive, oil and gas, and energy. Energy is extremely important to AWS, both in terms of the fact that data centers really are, to a large degree, massive consumers of megawatts, and they don't exist without energy, so we need a lot of energy. And because we're so committed to sustainability, that we are really interested in making sure that the energy transition happens as quickly as is reasonably possible. We're the biggest purchaser of, we're the biggest private purchaser of renewable energy, and we want to make sure that we're staying up to date. We sit on the NERC. A lot of people don't know that. We have a seat. We confer with the Rules Committee all the time, so we're pretty deep on power. My personal background, I joined an AI/ML startup that was active in power. Consumers was one of our customers at the very peak of the winter. It was 2001, the AI winter, when no one was doing AI. And our trick was we would close the loop on critical processes at power plants in order to ensure environmental compliance and cost minimization. So nobody wanted us, but we saved them so much money they had to have us. And that essentially put me in a place where I was touching real assets, where I was dealing with real constraints. And I really love being in that place, and power is getting right to that place. So you'll find that AWS, and I hope I'll be able to show you today some things that AWS is doing to kind of stay ahead of the curve, taking advantage of our, our real focus on the energy industry. So if we could go to the next slide, that would be great. So there are 3 Ds that are driving this digital transformation: decarbonization, decentralization, and digitization. I'm a business development person. I'm not really the sort of blue sky, there are rainbows and unicorns out there. Again, I like it, those constrained places. Flexible generation, the demands on how, in other words, I tend to be pretty practical and sort of tell things as I see them. The demands on generation to be very flexible are only increasing. We've seen that. Anybody who's on this webinar is probably very aware of the flexibility that's being demanded of the delivery process, and that's both transmission and distribution, and the way the transmission and distribution interact. And then finally, the one I'm sort of most skeptical of is flexible demand. And last night we gave up on a baseball game, and I said to my wife, let's go watch this movie. And we switched over to a web service, and my wife said, why is this taking so long? It was 12 seconds. And I asked her, would you wait 10 seconds to have the lights go on when you flick a switch? She said, no, I would not do that. So it's an interesting place where we are, because the sort of the strain is not being dealt equally. And by the way, we have to keep up with the things that we've always been doing. You have to be reliable, you have to be safe, you have to satisfy customers, as Matt alluded to, and you have to worry about making money for your investors. So this is getting to be sort of a place that is really interesting to a mindset like mine. My wife likes to say that when I get that first ding on a new car, I'm really happy, because, we're started here. So if we could go on to the next slide, that would be great. This is just another way to kind of, put some flesh on the bones there, which is electrifying 50% of the primary energy supply. And the push that you hear is everything's going to be electric. Gas is a transition fuel. We got our start in coal. That's an amazing thing to be said, but it is what's happening. Wind, solar. There are new business models being built out there in energy storage. We've been looking for the breakthrough in energy storage for like 100 years. So it's an exciting time. It's a challenging time. Decarbonizing customer energy uses. This goes along with electrifying it all. But how do you focus on efficiency? Electric vehicles and solar generation. Yeah, they're wonderful, but boy, their primary impact is sometimes a little bit difficult to manage. And CO2 management solutions. All of that is in the context of needing to remain very secure, and that's not just sort of having a secure energy supply. It's cybersecurity. It's fire and storm readiness, as Matt alluded to again. It's distributed energy resources, which in theory can, really, once they're widely available, can provide sort of a pool of stability that we don't have now. It's getting there. It's getting there where it's where there are some pretty interesting and some novel things to think through. So if we could go to the next. And this is my take on a slide that we have, which is to say that the energy systems that we've been talking about, they're in large part, the pieces of them are here today. You've got an expanding energy landscape, just in terms of all the players and all the different business entities. You have a more complex, integrated value chain, and that is going both ways. That's having, as Mir alluded to, and as Matt alluded to, that's power going both ways on the grid. It used to be unidirectional, and now it's all over. And evolving energy needs of customers, which again reflects the electrification of everything. And so we really do need to go fast, and it really is a fun part of the world to be in. And if we could go to the next slide. This is another one of the yesterday versus today slides. So the unidirectional world is over. Generation now includes a large slug of renewables. At the distribution edge, I think you see the biggest impacts. That's where you have the biggest problems with things like stability. That's where traditional tools that we've been using, as I think Mir pointed out, aren't adequate to the job. And once you can apply those new technologies, new things will open up to us. And again, the end state is going to be absolutely great. I have a good friend who's a smart guy, college educated guy, and he believes that every new solar panel is a step forward. And in a sense, I agree with him, but I also have a customer who built a really great diagnostic that's not doing the same thing that Sentient is doing, but it is looking out at the distribution grid for equipment problems. And he made a great analytic that worked on one part of his service territory, and he moved it to a part of the service territory that had less than 1% penetration of rooftop solar. and it didn't work. And in addition, he looked around at some of the equipment that was there to kind of maintain stability on the grid, and it looked like it was all calibrated wrong. And when they did their analysis and figured out it was because of that rooftop solar. So the point is, it doesn't take much. It doesn't take much to take something that's as finely honed as a distribution grid to start introducing some problems that need novel solutions. And I think we've seen other examples of that. If we could go to the next slide, that would be great. So I think we all can recognize this event. It was almost exactly a year ago. It was September 6th in California, and the Cal ISO, which has a capacity, the rated capacity is 51 gigs, and they exceeded that. And the actual demand was so far outstripping the day ahead prediction that sort of the most sophisticated piece of the response was a text that went out. But the most impactful thing, I believe, that happened was a live radio and TV appeal from the governor of the state saying, please don't use energy. Back off on your use of energy. And I want to point out one thing that he said and one thing that I haven't been able to get a number for, but I think it was sort of one of these unseen pieces of the puzzle, because not only were people coming home and watching TV and cooking dinner and all that drove demand, but the rooftop solar that had been available during the day was starting to peter out as they went through the end of the day. So I can't get a number on that, but that was a distribution grid sourced part of the problem. The other thing was that the governor made an appeal that if you own an electric vehicle, please do not plug it in tonight. And so that is all to sort of frame how big the challenge is, and just how much we need to rethink the things that we do and the data that we have in order to solve problems. I want to highlight a few of the things that AWS has been doing, and then kind of put that in the context of offerings like Sentient, and how if you're out there and you're thinking, how do I get started? How do I think through solving my problems? Just some of the things that I've picked up over the years and some of the things that I've seen AWS do really well. So if we go to the next slide. So this is something that is becoming very real. We are making progress through our minimum viable product chain here, and we'll announce when we have general availability, but soon. But basically, we're developing something called QBot. Now, QBot responds to the industry need. This came from directly working through with ISOs and RTOs. What was their biggest problem in getting new renewable farms sited? And it was the system impact studies and the intake process for those studies. We reference here that the wait to get a project approved is averaging 3 years. It's actually now, this year, it's more than 4 years. That's a long time to wait, and AWS does not itself, we don't want to wait that long to have these major projects cited, because we need to comply with our renewables goals. So we're doing a couple of things. We're automating a whole bunch of the process, which, as Monica pointed out, it was a paper process. And so we have taken weeks out of the initial piece of this process simply by automating finding errors and communicating those errors and getting updated. That can all happen in a matter of a small fraction of the weeks it used to take to get that part done. The other thing that was a primary consumer of time for the ISO was doing all the complex analysis of system impact with experts. So relying on human experts, that could take months to do, years to do. And when subsequent studies are done, they may impact your study. And it was an extremely arduous process. So we have, guided by experts at the ISOs, developed ways to use high performance computing and our custom chips that we use, like Graviton and other AI-oriented chips to greatly speed up this process. So our stated goal is to go from years to taking months rather than years. That is real enough that the ISO with whom we're doing some of this early work is sponsoring a FERC notice of proposed rules change with us, which is really great. It's hopefully going to make this a standard that can be used across the country, and this will help us to solve that problem of, okay, we need to have more supply out there. Now, that's not a specific distribution problem, but it's a big piece of the problem. It's something we're very proud of. If we could go to the next one, that would be great. Now, this is one that I think is really cool. You know, we thought that, you know, everybody thinks they're the most important person in the world. You might not have seen the press release on the Duke AWS collaboration, but Duke is really committed to embracing the cloud sort of full on. And we listen to you know, a bunch of what we do is we work backwards with customers, and we're hoping to find a customer framing of a problem that we can then connect to AWS functionality, and then we, you know, fashion that functionality ourselves or with partners to solve that customer problem. And we found a couple areas where we didn't have what we needed in order to do that. And so we kind of got an early look at one of them, which was power flow modeling. And power flow modeling, as you probably know, takes weeks or a couple months in order to do. It's used as a way to figure out where to invest in the grid. Duke in the press release has a stated objective of getting to a 15-minute or less periodicity for doing these studies. That's a tremendous leap forward, and it is almost, in my mind, as an old closed loop guy, it's bringing things into this realm where, you know, our first optimizer, it acted every 15 minutes. Well, now we've got really good data, and we've got some control options. Believe me, I'm not telling you anything about what Duke is thinking, because frankly, I try not to know. But what I would like to point out is that this involves the Amazon Industrial Products Group, and that's the group that finds these opportunities where the software instances, the silicone, the IoT resources just don't exist. And we work out with the customer how we will invest in that infrastructure and bring that infrastructure to market. They will invest in the application that sits on top. They can bring that to market, but we are enabling a brand new technology. And we think that this type of view of power flow specifically is going to be interesting to the industry, and is going to be something that that others can also use, whether they want to build their own solver on top or somebody else wants to build the solver for them, which is why we're investing. But it's a really, really cool thing that we're doing, and it lives right there on the grid. It is all about what's going on out there. If we could go to the next. This is another one that we're pretty excited about. This is a company called Vector. Vector is a New Zealand utility, and our partner here is a subsidiary of that company. If you're looking for development on the grid, insular and peninsular places are a great place to start, because, you know, they can't be Ohio, they can't be Germany, they can't be part of a big, you know, networked solution. They are isolated or nearly isolated. And so they have problems around maintaining phase and other things that are really important to lots of grid players. In Australia, where Vector won the business, there's 5-minute settlement. And so 5-minute financial settlement is a tremendous goal. It's been met, they're meeting it, they're active, and it required that Vector develop new applications to finally really manage all the advanced metering information that's out there. And they can see at a very, very granular level, and they can see very, very rapidly. And again, this is an AIP initiative because the underlying infrastructure to achieve that didn't exist. And so we had to create that. And so I'm pointing these out because I think the grid is a very exciting place to be, but we're also gaining a lot of insight, and we're making we're breaking new ground that would hopefully be useful to you. If we can go to the next one, and I'm going to speak as briefly as I can about this. I believe we have the best cloud. We have the most services. We have the deepest. We have more availabilities. That we could go on and on about that forever. But one thing that really impressed me as a guy who got started out there on the edge is that Amazon Web Services is really invested in that as well. So we have on-premise offerings that will enable you to use AWS-like applications, be in our environment, but not have to be on the web, but make maybe some historical data available. We know there are NERC things that would get in the way. And we have other options up and down the line. And that really excited me, but this is kind of sounds like I'm selling AWS. It's not really what I want to do. I mean, I do, but not in this form. So if we could go to the last slide, that would be great. So I just wanted to go over and ask the question, what future are we preparing for? It can be easy to kind of be deer in the headlights when you look at how fast the infrastructure for understanding your infrastructure is developing, and to not know where to start. And so I would just begin by positing that no one really knows what that whole landscape is going to be, and it will continue to evolve, but sort of we're in the place where it's being born. We can't tell. We don't really know what it's going to be out there. So what should we do? Number one, let's recognize that the grid edge is a source of a lot of opportunity and a lot of instability, and applying new technology out there, as Sentient has done, as Matt's shown you, he's been able to drive value from, really important. And the questions I would ask are, does a company or a technology drive value today? If so, there's a good chance that no matter what the end state looks like, that's going to be a good investment on your part, and a good investment for us in terms of partnering and sponsoring. Does the company or technology have a loosely enough defined vision of the future state? And by that I mean they're not overcommitted, so that they're going to be responsive and they're going to learn as we all develop. And have they demonstrated the ability to integrate with the hardware layer? Throughout my career, it has been a fascinating and frustrating, like, wrestling match to get data scientists and mechanical engineers or electrical engineers to wrestle out what is the solution, because they're so different. If you only live in the cloud or you only live in a software environment, it's easy to believe you can conjure up a brand new reality, and to a large extent you can. You get a lot of these things like, call it Airbnb or Netflix or, you name it. It didn't exist. They created it out of nowhere. What happens when you're up against the grid? What happens when whether it's thermodynamics or it's the science of how power flows? What about when those are your real obstacles? That's when it gets fun. And if you can show that you integrate well with that, I think that means you're probably a survivor and probably worth looking at. And I think what we saw today does demonstrate that. So I know I'm coming right up on it, and I'm looking forward to any questions. But it's an exciting time to be in this part of the world, and thanks for listening to me.
Hey, Peter, great stuff. You raised some really good questions that I hope that we'll be able to address. And I don't know if we'll be able to answer them completely, but at least toss some of those ideas around, because it's really important stuff. We've got a lot of really great technical questions that are coming in also, but during the panel discussion that's come up in just a few minutes, we want to maybe talk a little philosophical about what all this means for the utility industry. So we will get to that. Peter, great job. Thanks very much. Well, what do you say, PJ? Should we get the panel discussion underway?
I think so. I want to invite all of the panelists to go ahead and turn your cameras on and come off mute, and I'm excited to see how the conversation goes.
Great. I'm looking forward to it also. This has just been a really great session. First of all, I just want to congratulate everybody for a really interesting talks and insight into these issues. And I've been jotting notes down as we've been going along, and some of the things that have jumped out at me have been climate change. Mir pointed out the window at the skies that are no longer as blue as they ought to be as a result of climate change. We've got talking about electrification. We're talking about extreme weather events and wildfires. Peter talked about the unidirectional days are over. All of this complexity is taking place, and so much of it is funneling in on utilities and their ongoing ability to deliver reliable electricity, number one, and then also minimize the outages that take place. I wonder if, let's just take a minute and step back and maybe not talk about the specific technology, but maybe let's talk about the added complexity that utilities are facing and the depth of change and the range of tools that really need to be used in order to help ensure reliability in this underlying idea of predictive and not reactive responses. Mir, I wonder if you'd care to wax philosophical for a moment on that topic to get us started.
Yeah, thank you, David, for the question. Yeah, so as I highlighted, I think when we look at the range of problem we're solving, there's always two sides to the coin, right? There is the technical aspects of it, and then there's the business aspects in terms of change management processes and how does it really affect what we do today. And I'll be the first one to admit, change is not good in general, right? Because we get used to how things work and we get better and it's efficient, and unless there's a strong reason, why would you, essentially, right? So I think the biggest element of managing the rest of the step in the workflows is all figuring out what are the new motivations, how do we get motivated to go over that hurdle of change now is good and actually needed. So I think that's important to hit it from multiple steps, because I think the change has to also deepen the organization. You start from the top of the pyramid, you go all the way to the down, because the reality of it is that when we work, for example, Matt talked about how we are, they're starting to, talking to their field crews. We are also relying on the accuracy and their dedication of the results and the data they're bringing back for us, right? And this has been historically a challenge in the past, where, let's say, how do you get consistency, in that action, and how do you actually communicate the importance that every simple node, every simple data point that you bring them back into the operation is actually going to make a difference in this process. And so, how do you go deep? How do you motivate that? How do you actually kind of also reward a good behavior? Monica talked about human behavior, and that's a piece of it that I don't think physics can give us a lot of clues. It's not something I can write an equation for it. So I'll probably stop there. I'm sure there's other experts, and Monica, you probably want to weigh in and really offer your view into this. But I see this as a, start with a technical thing, but also be mindful that at the end of the day, human behavior is the longest pole in the tent, and we gotta have a holistic view and have a plan for how we're going to achieve that.
Yeah, Monica, would you like to weigh in also on this idea of the added complexity that utilities are facing and how to think about some of this?
Yeah, so my perspective, you're absolutely right, Amir. With regards to data that comes back, I do believe that overall, though, we do make it very incredibly hard for those field employees to be able to collect information in a very much automated way. I would say that tools are getting better. As we had heard from John previously, there's a lot more tools that are being put in the cloud, so it's very much modernizing in that space, especially when it comes to field service mobility tools. However, is that enough, right? We tend to apply a lot of parameters around field data collection, but also accounting requirements to our field employees, when their primary responsibility is to either make safe, complete the repair, do the installation, and making sure that there is actually reliability in the grid. So I do think that as we think about innovation, we think about opportunity, that data element and the ease of capturing that data needs to be a much more easier process than, you know, than what it is today. And that really starts all the way from the storeroom, from a materials traceability standpoint, all the way through the entire work management value chain when it becomes as built into the field. So, so there's a bit of a broader perspective there that we need to take a look at.
Yeah, yeah. And Matt Henry, from the utilities point of view, you know, you've got a regulator that you have to be responsive to. You've got the entire business case that has to be put together, along with dealing with trying to manage additional complexity that electric vehicles and that distributed resources bring. How does that talk a bit more about the complexity that you're facing in the day-to-day environment that you're working with?
Yeah. Well, I'll start by saying complacency is the enemy. So I'm a little biased because I'm in grid modernization, which you could replace grid mod with change management. I mean, that's what we do on a day-to-day basis, is we're managing change and new technologies. And so with regulators, you're developing business case. We want to explain why regulators want to improve reliability for customers. We want to improve reliability for customers. Why is this specific technology the right one? What's the sound judgment and reasoning for why this one's much more valuable? I think that artificial intelligence has really opened some floodgates for automating processes, automating solutions and data. I mentioned in my presentation, utilities have gotten really good at collecting data, but data on the surface isn't going to do nothing for you. So it's how do you improve, you look at it and consider it and alert and act on it to improve the ease for our crews, our linemen, and our engineers and throughout the organization.
Peter, do you want to add anything around AI in particular? That's an
Yeah,
interesting.
you know, having worked with AI, it was like a taboo thing to bring up that we were using AI when we first brought it up, because it was a black box. It couldn't explain itself. It's inherently unsatisfying to engineers. And so for it to be this calling card that, you know, you can literally, oh, well, AI is going to handle that. Oh, of course, AI is going to handle that. It's kind of funny, but I think one thing to the point about utilities being really good at collecting data, they are really good at collecting data, and they were sort of forced into, and I'll just use this as an example, into installing a bunch of you know, advanced metering systems, and at the same time they are not rewarded for operating costs. So the cost to maintain a lot of that AMI data, which would be really useful to AIML right now in terms of having a head start to you know, mine that for knowledge, never got stored because it was really expensive to store the data, and so it was deleted and we went into the billing system, and that was that. So it's one of these, you know, cart before the horse things. You know, do we have a need for that data? Well, no, we've never had that data. We don't know what it might be good for. Well, then we can't store it. And so that sort of, and that is inherent in the way that utilities are regulated. And so the complexity, you know, Mir pointed out that the SCADA type of data that was collected wasn't enough. They needed to go one layer down. I think that some of the complexity that's going to come is going to be both driven by that next layer down and resolved by that next layer down. But we've got to get there, and, you know, Matt's right. You've got to say this is a prudent investment. It's something that's going to provide me with the payback, which I think it sort of dovetails nicely with my idea that you don't want to buy the moonshot right now because no one knows, you know, where the moon is, right? You want to buy pieces that work and put them together and that drive value now, and they will get complex as time goes on. It's sort of like trenches meeting in a war. You know, like they're starting to link up. I can see it. I can draw a line between the Duke work and the vector work. I can kind of do that now, and the sentient work goes right in there as well. So yeah, the complexity, some of it's self-inflicted, and I mean, look, a lot of it used to be taken care of by a prudent investment was a pretty healthy reserve margin, and so you'd have reserve margins, kind of over-engineered everything, and so you would have, safety and security would be your first two things to address, and you get it that way, and that's kind of disappeared. So we're getting the bare metal here.
And Matt, I wonder if you could talk a little bit, because we've had a number of questions that are coming in from people who are really interested in understanding what your business case looks like for this. Is there a return on investment expectation for preventative action? Is there some other way of justifying it? I want to hear how you put it together, but then I also am interested in hearing from the other panel members what your experiences or what your thoughts are in what an effective business model looks like. But Matt, could you take the lead in talking a bit about how the business justification was crafted? And then just one thing right after that, PJ, we'll take a look at those poll answers. So Matt, go ahead and do that, and we'll have this full discussion and then the poll.
Yeah, sure thing. This is one of those fun engineering problems, because there's really not the right answer that you go find and you discover here it is. I saw some of the questions in the chat are asking, how did you fall on this number of sensors? How far apart are they? Those are the fun ones. If you're a nerdy engineer like myself, those are the things you like to do on a day-to-day basis. And so the right answer is somewhere between, we have communications at our substation, we have AMI at the endpoints, we want visibility in between. There's lots of different scenarios for what makes sense depending on the utility and the circuit and the region in different parts of the state, and then you build in climate change things. So it's a complicated question to give one right answer to, but we consider all of that in the business case. So we want to show, one of the key points I made was that 70% reduction from moving from reacting to something in an inconvenient time to being proactive is a 70% cost savings. So that's one that we leaned on. We tried to use those numbers. We use actual circuit reliability to say, on average, it takes us this many minutes to restore something. We didn't have to do that, and it impacted 100 customers. You multiply those together and say that many outage minutes didn't happen because we did this thing. So those are really what's driving our business case. Safety and reliability are the two key first priorities that we build in up front. And then part of that phased approach I talked about, where we didn't say, let's turn this on everywhere in the system all at once and try and boil the ocean like Mira mentioned. We wanted to say, here in this limited size, we think we can do this. Now let's expand it to, let's double it, and let's see what we get here. Next year, if we double it again, now you can start to forecast and use actual real data to say, here's what we expect, and it's based on sound judgment, and the regulators get on board, and then we can move from there. So yeah, good engineers who can solve those problems are going to be your friend. I'll leave it at that.
That's the key. That's the key. Mira, I wonder if you could add your thoughts on what the business justification magic bullet looks like.
Yeah, well, that's. I mean, if the audience wants to take one challenge from the panel and get back to us, it's exactly that problem. I think it's interesting. Matt talked about engineer problems and all that, and when we solved the engineering problem, technical problem, we thought we were done, but we just realized that it's actually beginning of the journey, because now the next question is business problems, right? Valuation, and the question really to the panel and to all of us here and to the industry. I think we actually posed this in our social media as well. When you take actions to prevent a future that was destined to happen, it doesn't happen, so the outcome hasn't happened. How do you go about valuation? What metrics you actually use? Because I think, we've gotten very good in coming up with quantification of value and business justification for things that do occur and they are factual. But if you take action to prevent that, and now you have a different outcome, which is good, right? But it doesn't give you the actual data to then go about the conventional ways. How do you do that? So again, I'd like to just congratulate Matt and the consumers team to just help us work through this. We came up with a model that, as he described, builds on things that are known, and we're taking a methodical approach of proving and validating and asking the next question. But in general, I would say, as Matt said, I don't think that's one way of doing it. Very factual driven and all that. We use estimates of KD for the circuits and the impact of an outage. And again, in our data, we actually now start leveraging the 5-minute log eye data as an alternative for what the impact of an outage would be as well. So there's additional layer of information coming in that way. But I don't think it's a single, it's just that one. I think we've heard from our other innovation partners how they are thinking about it. Sometimes it's the customer count impacted is the way to go. But yeah, I don't think there's a silver bullet. I don't really have, we're thinking through that and we're working with our partners to come up with different models. The good news is that I believe it's not too many. It's discrete, it's finite. We just need to figure out what it makes sense in the construct of the utilities that we're working with in their regulatory environments, in how they actually go about valuing, justifying innovation projects and things that are especially really kind of breakthrough and not done before in a massive scale and all that. So open question, we've got some answers, but we're still looking for more.
Yeah, good.
Yeah, I mean, I would just, sorry, go ahead.
No, go ahead.
Well, I would just throw in that, consumers pointed out at the beginning of their presentation that they are primarily rural. They have lots of miles. And so they're really threatened by these unplanned outages. And it has a really adverse effect on them. And I would just point out that our three most innovative customer types are ones that are either required by their regulators to embrace cloud technology, and that's never done explicitly, but you have to use data, you have to keep up with these, this rapidly changing regulatory structure that we have, or there are customers who feel threatened, and I would say that insular, peninsular places are places where the threat is real, or it's companies that have experienced a negative event. And I just point out that of all the three things that I mentioned that AWS is doing or also actively investing in, none of those would you want to try to execute on an on-prem data center. The compute and the storage and the data needs are just way too big, and you can't charge for that. I mean, when AWS rolls in with the traditional replace your CapEx with OpEx, the utility industry says, you're killing me. You're killing me on both ends. But I think there are real hard problems that the whole industry is going to have to solve that you're not going to be able to solve without the cloud. And so I'm just throwing that out there as, we're ahead of the curve maybe, but when either the threat comes or the negative event comes or the regulations come, we'll be there.
Well, and Peter, so just to comment on that, right? I do think that there is a need to evaluate those regulatory frameworks. We do a study called Digitally Enabled Grid, where we survey a number of executives, and your commentary about the threat and the tipping point. 86% of executives believe that tipping point is going to happen within the next 5+ years, right? In this next decade. And they're already seeing 100% of the executives are seeing some sort of disruption associated with that. So I do think that there is a need to have a very frank conversation around whether it's, around cloud capitalization to incent the right things, because as we all know, historically, like the once data is captured and beyond that, oftentimes data cleaning and cleansing tends to be an O&M activity. And so data quality issues do exist, and we have to treat data as if it's currency. It needs to be accurate, reliable, secure. So we have to take that lens in order to do right for our customer base.
Well, PJ, let's take a couple of Oh, go ahead, Peter.
Yeah.
Oh, John, did you have a comment? Yeah.
Yeah, I just wanted to kind of comment on everything we've been hearing from the business case, as well as the challenge on data and kind of the pace of change. And when talking to our utility customers, and I'm sure all of you on this webcast realize that each utility is unique and different, right? A municipal versus a mid-sized utility versus a large IOU may have very similar issues, but in the same sense may have very different challenges within their utility footprint. When we talk about decarbonization and all the renewables and DERs coming online, historically, at least the pace of it has been, mostly on the West Coast of the United States or the East Coast. But now that's, it's changing, and there's more change coming. But I just wanted to, point out that, each utility will be different and have their specific issues. In regards to the data and the challenge on data, I think the first thing is obviously utilities are collecting a lot of data, and that'll encourage, cloud investments. But I think before you even collect more data, maybe, build it into the business case. What are we using the data for, and what's the end game? What are the metrics that we want to improve, whether it's, improved outages, just lowering overall O&M costs, improve safety. Are there pain points that you already have that you need to improve on, either internally as a corporation and as a utility, and it, or the regulators already, pointing things out to you that need to be improved. So what are those metrics? And just going back to the data, it's really kind of just understanding the end game and getting that business case in order. And that's just really, to be able to do all of this and bring technology forward, there needs to be collaboration between the lines of business with operations and the IT folks to enable this. So really understanding it from an operational business point of view, what do we want in the end?
Good stuff. PJ, let's take a minute and take a look at the poll results, which we promised everybody, and we can talk a little bit about those and see if there are any surprises. What's the top cause of distribution outages at your utility? And as they say, the survey says weather and vegetation. Maybe no surprises there. Anyone see anything surprising, or not really?
It's consistent with the pie chart that Matt shared previously.
It is. That's what you're seeing, Matt, right?
That's exactly right. And one thing I'll just say about this that I think most utilities can relate to is a cause code for an outage is a fun topic, because if you see a weather event that causes a tree to land on a transformer, I could see all three of those falling in the cause code of the outage. So that's where the data collection piece, we really need to improve definition and standards for how do you classify this? What is it that failed? Was it the wind? Was it the tree branch that fell? Or was it the transformer that broke? So it's a fun topic that I think everyone's struggling with. But I'm excited to figure that one out.
That's a great point. Good. PJ, can you show us poll number 2? Here we go. How likely is your utility to deploy software in the cloud? You're already using cloud software deployment, 57%. Peter, what do you say to that?
I think I'd love to see that number reflect, sort of, I wonder how much they're using the cloud. I wonder how much of their data they have in the cloud.
Do you have any metrics around that? Any sense?
I do not. Well, my sense is that there's still substantial reluctance to put, sort of NERC SIP, certainly, even though we've gotten storage blessed by NERC and FERC. There's reluctance to put sort of mission critical data on the cloud. And so you can do your web page, but are you collecting and storing all the analytics on your transmission and distribution grids, or, are you making, generation data available to all the AI and sort of data enhancement tools that we could use on the web? That I think it's very, very uneven. I think we have a few customers that are pedal to the metal, and we have others who are getting their toes wet.
Yeah. John Vallali, do you have any answer into that?
Yeah, I was going to say I can confirm that these numbers kind of are in line with what we're seeing, especially with all the survey data that we put out in terms of cloud adoption, and especially for U.S. figures. I think we have 60 to 65% of utilities are using cloud in some fashion, and the question is where are you using it? So there are few utilities that are using cloud up and down the value chain. But what we are seeing is, the use of cloud more within operations. Historically, cloud and the first step in cloud has been kind of in the CIS systems, and those are a lot of them are outdated and legacy systems, and kind of that's where we saw the first adoption of cloud. But as we move into operations, as I mentioned before, I think there are some restrictions and hesitations for good reason on the generation and transmission side with very sensitive, critical operational data. But those restrictions and NERC-CIP, constraints haven't really been applied as much on the distribution system. So I think when we get into those type of applications, such as the ADMS, a DMS, we've talked about field services quite a bit. We are seeing cloud deployment there quite a bit. So I think, this 57 number, I could even put it a little bit higher. And obviously, if you move into, Europe or other, utilities specifically that are a little bit more progressive, that number obviously can be a little bit higher. So moving in the right direction in terms of cloud adoption.
Yep. And Matt, can you comment on where your utility is here on this survey? Where might you place it?
Yeah, definitely. I think we're firmly in the 57% bucket of already using cloud software deployment. I am a firm believer that the future of electric utilities, compute power and capabilities needs to move out of a centralized box and throughout the grid where the magic is happening. And so I do think more and more just the capabilities of computing and what's needed in more real-time response is going to drive towards that future.
Yeah, good stuff. Great. Well, PJ, how about the third question? What is your largest barrier to the changes required to implement advanced analytics for preventing outages? Budget, 63%. That's kind of what I thought. I hope I didn't skew the poll by saying that live, but that was my guess. Any of our panel members have a comment? What do you see? Is this surprising, or is this about what you would expect? John or Peter or Mir or Monica? Any?
I think budget is always going to be an issue, even without the CapEx, OpEx piece complicating things. But the technical expertise is, I don't think that's limited to power and utilities. The cloud is new, right? And the skill base isn't, it's not there. So we offer a lot of different ways to learn about how to use the cloud, what the cloud is, what the pieces are. I know that the industry has a preference for buying solutions rather than, being builders. I think Duke is exceptional in that way. But technical expertise, even to be able to work with a partner, define problems, recognize opportunities where things like AI, ML can help. I think that's sort of it's a chicken and the egg thing. But to get ahead of that, to build that layer so that you can think through the options, that's really important. And so if you kind of take budget as, everyone's going to have a hard time with budget. I think this is a pretty accurate thing, that technical expertise is, it's not just perceived. That's a layer that's got to get built up. And partners are a great way to go. If you want to learn, professional services from us is a great way to go. But building that technical layer, I would say that exists in finance and automotive and just everywhere. It's all over.
If you take a look at this, right, the three categories here around whether it's technical expertise, executive buy-in, field crew readiness, availability, all of those are in some manner or fashion are people related topics. And so if you think about it, in the context of technical expertise, there's the interim in terms of putting in the initial piece, and you can certainly get providers to support that, but also building some of the technical expertise in-house to sustain it long-term is another point of discussion, right? I think executive buy-in, I think one of the things I did emphasize is, are we truly aligned across the executives with regards to what we're trying to achieve in the context of outage prevention? It takes more than just the control center and control center operations to make this happen. And how does that then also get prioritized with regards to the field crews and what they're working on? How can we talk a lot about like having appropriately planned work, and we're putting in all these new field service systems to be able to support aspects of management of that work. However, if you're in a continuous cycle where everything is emergent, that also becomes a bit untenable in order to do some planning around that. So the three sections in the middle are all people-related topics in one manner or another.
Yeah. And I just realized that I might have just sounded pretty arrogant, was just saying the technical expertise doesn't exist in the customer base. I think broadly in cloud, at least until the last few years here, I can speak to, we were pretty good at talking to builders, but we didn't really put a lot of resource into understanding the line of business and the real sort of realities of what that our customers are dealing with. And I think in the time that I've been here, we made a much bigger, especially in power and utilities, a much bigger push to build that in ourselves. So I didn't want to come out sounding arrogance there. There's a gap has two edges, and I think we're aware that our edge of the gap also needed to be filled in, and so we're trying.
Yeah, great clarification. Good stuff. Matt, I wonder if you could comment on what Monica mentioned just a moment ago, which was this idea of being able to manage where the priorities are. Everything raises to a certain level, and how do you how do the work processes become impacted, and how do you what's the best way to integrate these predictive tools within the existing work structures that you have?
Yeah, well, my first impression when I saw the poll was I was happy to see that the largest barrier was allowed to have multiple answers. So there are multiple answers to what's the largest problem, because I think that's a great way to put it. The people question impacts budget and impacts schedule. The fifth one too is the schedule. So I do think that it really comes down to creating the business case and creating the value that it provides when what compared to an alternative. You really have to say, if we don't do this, what are we sacrificing? It's an opportunity cost question just as much as anything else. So when you develop that sales pitch for why we need to do this, you need to accurately reflect the outcome of not doing it just as much as what it provides, if that makes sense.
It's absolutely, I agree with you, because it comes back down the business case and the impact to customers as a whole. That's why there is a case for change. There is a case to make, and it does stem around perpetuating a new type of behavior within the organization.
David, if I may, on the poll that we had, so I don't know that we can do a lot with the budget, other than obviously advocating for the change and producing outcomes and results that kind of shows and makes results tangible and all that for regulators, for customers, for our sales as well. But when it comes to technical expertise, I think that's part of the reason I think we sort of pride ourselves in saying that we are also fast time to value. And if you think about the architecture of the solutions in IoT in general, in particular the solution we just talked about, it really brings pretty much every technology piece that you need in terms of hardware, software, communications, and all that, right? So our approach pretty much have been take away that complexity so that we also reduce the barrier and reduce the standard of what do we need from your end, essentially. And when I looked at the workflow, taking away that abstracted that complexity away, making it easy to use and digest and again, produce a product or a solution that can be adopted, slowly and scale according to the phase approach that Matt mentioned. That's one of the ways to concur that, right? Because certainly you could argue that you could start big, and obviously you can also start looking into the deeper layers of technology stack, and that's where you can actually be heavily influenced by, do I have the right skill set? Do I have the right budget? Do I have the right emphasis and priorities across the board to make it happen? I think for us to really be successful in this domain and make sure that, to Peter's point, this is not another AI winter, which doesn't appear to be the case at this time around. We really need the partnership approach, and it's basically proven to be very successful across many industries, including ours.
Mm-hmm. Monica, I wanted to ask you and have Matt weigh in on this also, and Mira as well. I'm interested in the regulatory buy-in and what conversations you have with regulators in terms of using these kinds of predictive tools. And Matt, I'm interested in particular, you were talking about how you targeted these specific high-risk areas and kind of work things into part of the wildfire mitigation strategy that the utility has. I wonder if that's a kind of a regulatory thing or just what the thinking was around that. But Monica, I wonder if you could talk a little bit to start off on getting regulatory buy-in as part of this change management approach.
Yeah, so I think it comes back down to broad emphasis around the case for change across the industry. With respect to having conversations with the regulators themselves, I think we equip our clients to have those conversations, right? In terms of the context and also why it may be important, and provide that perspective with them so that they can take it upwards. Now, having said that, we are involved in a lot of different external panels such as this and others to help articulate the messaging across the entire industry around what is necessary to handle the disruption that is facing us. I think that there's wide acknowledgement that the disruption will happen, or it's going to happen already. And so, providing that perspective and that influence and education, not only amongst our clients, but also externally within various panels and points of views, is how we try to shape and share our perspectives in this particular area.
Mm-hmm. Matt, could you talk just a minute about the regulatory approach that your utility has taken?
Yeah. I'll just say value takes the form of many shapes and factors. So how we provide value is a tough question. So it's not, we want to prioritize the best way possible, and it's a two-way conversation with the regulator. We want to make sure that what we're doing is in line with their thinking as well. So there's obvious safety, reliability. I've talked about the cost of doing something. Those are all important values, but impacting disadvantaged communities, environmental justice, risk avoidance is value, and specifically wildfire, high-risk mitigation areas. How are we incorporating those other high important values into whatever it is that we're deploying is very important. And so we want to listen to our customers through the regulators and make sure that what we're delivering meets those values, and it's across the board. So this program specifically is a perfect example of how we can do that. We can take a wildfire risk map and say, all right, we're going to deploy new proactive analytics. Let's target those areas where there's high risk of vegetation making contact, which could catch fire. So that is definitely built into our thinking. And then it's the communication to the regulator so that they know that we're doing these things and we're listening and the voices are heard.
And Mira, you had a comment you'd like to make?
I'll just double down on Matt's.
One question, Matt, did you make the point to the regulator that by being able to schedule this maintenance work, you weren't doing work at night, which was an enhancement to safety?
I will say this is relatively new. So we've only had a couple conversations so far about the technology. It's more of the learning phase. We've gone through the proof of concept, but in our next regulated case is when we'll really have that back and forth where we educate. I think we've now got to the point where we can have that conversation, and we will include those types of things in.
America,
Specifically, yeah, not having to work at night, it's safer inherently, right? So that would be a part of it.
Yeah, of course. Yeah, it's good. Yeah. Mira, I've got a question for you. In particular, are the sensors placed on the line or at the substation, and can they be used on transmission voltages?
Right now, we can go up to sub-transmission level. Usually, we would just say about 35, 45 kV and below. So that's the limitation for nanotechnology. But from the analytics perspective and all that, again, we're taking a first principle approach. So if there's a strong enough use case and data associated with it, we're not shying away from the challenge. But right now, we're decided to attack the core of the problem with a lot of exposure that we see at the sub-transmission and distribution level for these applications.
And in the case of mass utility, are there any communications issues that come into play when you're dealing with a predominantly rural utility?
Yeah, I would have given a different answer 10 years ago, or maybe even 5 years ago. Today, it's something we monitor, but we really haven't seen any wide-scale communication issues. We do diversify between service carriers, Verizon, AT&T, and do some studies beforehand, but it's really not as big of a communication issue as one might think, or as in years past it might have been.
And Matt, how did you work with Mir and his team at Sentient Energy to determine that 12,000 devices was going to be an optimal number for the business case? How did that work? And Mir, could you talk about that also from the kind of the technology perspective?
Yeah, that's that fun engineering problem. Is it's based on the size of your system, the factors like the length of your circuits to determine how many can go there, the loading, even though it might be a 100-mile long line, all the loads in the first mile, that impacts how many you can put out there. So the 12,000 went through a long study of our circuits, our layout, the geography. I saw a question that asked about how far apart they go. That varies on all those things, but a rule of thumb that we try to do is segment 1 to 2 mile zones. It's typically what we do. We absolutely, anytime the circuit spurs in different directions, we try and make sure that both of those spurs are covered and we have the visibility in any direction. And one thing I didn't talk about, but we do have 2 versions of sensors that we're deploying from Sentient Energy. We have the MM3 is the main one. I think about 90+% of our sensors are the MM3, but there's also a low current variety. So the ZM1 is capable of lower currents. And so we do have those in certain areas where they're high priority to get in a part of the grid that has a little bit less load. We can deploy those as well.
Great. And Mir, can you add any technical insight into how the 12,000 was arrived at, or what some of the considerations are?
Yeah, absolutely. So as Matt mentioned, it's if you really think about your engineering hat, it's a multi-objective optimization problem for those in the academics. It's a great problem to solve, but we try to simplify it. Engineering rules and all that, obviously use case first, outcome first, and then you kind of backtrack from there essentially. So there are, as mentioned, there's a lot of circuit considerations, there's load profile, there's loading, there's wireless communication, all of these issues. Okay, so that gives you one set. Then the other set of it is about, okay, if you want to be successful in not having a lot of misses, right, in terms of, okay, things are happening, it didn't make it to the head end, or we see something, we want to maximize the opportunity of what I call it find and fix processes. You look at the bifurcation point, where the switch points are, where the cap banks are. For those in the audience, cap banks are a good shunt to the ground. They suck in all the high frequency stuff. They don't let you pass them essentially, right? So it's a multi-objective. We have a formal way of what we call placement studies that we do, that essentially if the feeder models are available, we can actually run load flow models to look at the loading, because in some cases, actually, you don't know what the loading is. That's the primary reason why you want to put the sensors in. So anyways, we do a combination of load flow studies, looking at the wireless maps and look at, of course, use cases and ask some of the questions technically in terms of the assets on which models will give us to. And as Matt mentioned, there are places where the minimum current needed may not be available. So there is a variant of the product that allows us to actually go to low amp or 0 amp. We call them ZM1 for that reason, because it does not require any harvesting from the line, which covers long laterals, low load conditions, and all that. So I think that we, from the sensor portfolio perspective, we're in good hands. I mean, it just depends on where the opportunity is out and all that, and it's just all about create an initial concept to go around it and expand from there, essentially.
Nice.
And just very briefly to add on to that, I just want to say it's a multi-objective problem because even loading is a snapshot of time. Right now, it might be different in the summer and the winter. And so a cottage type load where there's only summer load is different in parts of the year. And so it's a really fun challenge.
Good stuff. Good stuff. Very nice. Well, that's all the time that we have for today's session. As BJ said earlier, it's just rocketed along. Let me thank again our presenters who included John Villali, Matt Henry, Monica Young, Peter Kirk, and Dr. Mir Musavi. Thanks to each one of you from the panel. And thanks again to Sentient Energy, a Koch engineered solutions company, for sponsoring today's event. One note to our audience, watch for an email from us containing a link to the replay. Please take a moment also to complete our survey at the end of the session. Your feedback is always appreciated and will be used as we plan future sessions. From everyone at Energy Central, I'm David Wagman, thanking you for joining us, and we look forward to seeing you on an upcoming power session. Thank you for attending. This concludes today's presentation.
Thanks, everyone.